Today we're talking about yield of a chemical reaction, as you can see, and it's actually a pretty simple idea, probably one that you don't really need to be explained. However, we're going to have three pieces to this. Number one is how much did we actually get from a reaction? It's always going to be concerned about a product. Another one is how much were we supposed to get? Think about a test on this one. Test is what the test is out of. That's how much you could potentially get, how much you're supposed to get, let's be honest. And then what you actually get is usually going to be less. And then we want to compare the two. And the reason I mentioned a test is because how you compare what you actually got with what you could have got, that's how we're going to compare these as well. Now, we're going to have separate terms for each one of these things, so you don't need to worry about, I'm just going to throw the word yield at you, and you're going to have to figure out what to do. It's going to be pretty apparent. Okay, so we start with a theoretical yield. And theoretical yield is the amount that you could get if everything went perfectly. Doesn't really matter how good a work you do, it's never going to go perfectly. You're never going to get 100% yield. Test maybe, chemical reaction not so much. So as I said, it's generally not achievable. Chemical engineers will spend years and years and years trying to just sneak a little bit more out of a chemical reaction at the industrial level, because every little bit is savings. Every little bit more is profit. It's a calculated amount. All right, how much you could get is going to be a calculation, which means it's going to be stoichiometry, which we already know how to do. And the question is going to look very similar to this, where what mass of product can I get if I'm using this much reactant? And it's always going to look like that. Now, stoichiometry in general is always how much of one for this much of the other, and it doesn't really matter. But theoretical yield is just a stoichiometry question where how much product from this much reactant. So, for example, here, there's a question, how much mass of aluminum oxide can I get from 86.5 grams of aluminum? Okay, I'm not going to spend a whole lot of time going through how do we do the stoichiometry. You already know how to do that, but it's just a stoichiometry question. Notice it doesn't even necessarily say theoretical yield, calculated theoretical yield, but that's what we're doing. Okay, we don't have to do the experiment. As soon as you know the question, you can figure out theoretical yield, how much you should be able to get. So the stoichiometry would look a little bit like that. Yeah, there's other ways of doing stoichiometry, but in this case, that's what I did. And you'd get a mass, theoretical mass of 163.4 grams. Could you actually get that much? No, probably not. Is that a problem? No, probably not. So the actual yield, that is, I have to do the experiment, I have to do the reaction and collect actual product. Or I have to tell you somebody did the experiment and collected actual product. That's another way to do it. Okay, so you actually have to do that work. It's a measured amount. Okay, so theoretical yield versus actual yield, one is a calculation, the other is a measurement. Does it really matter? Keeping track of which one is which? It might. Okay, someone has to do the experiment or somebody has to tell you what they got. I'm not going to give you an example of that because it would just be in that previous one, they actually did the experiment and collected 72 grams. Okay, percent yield is a comparison between those two, and it's exactly how you would do a test, which is why I've mentioned the test. What you actually got divided by what you could have got. Now, mathematically, that should be presented like this. We often do that times 100 part in our head. So if you get, I don't know, 40 out of 50 on a test, then you do 40 divided by 50, you get 0.8, and you say, I got 80%. I hope I did the math in my head right. And that's right. With this one, because the numbers are going to look a little bit less familiar, I'm going to really strongly recommend you do the times 100 so you don't miss that step. Okay, and it's really just like that. The actual mark on the test divided by what's possible, and we really should multiply by 100. And that's it. We got time for a quick chemistry history story if you really want to. No? Okay, that's fine. That's what we're going to be doing then. Talk to you another time.